Hello everyone, I'm Ray Okumura. Today I'm talking about feasibility study of magnetism-based interpositioning methods in an incineration plant. First, I'm talking about a furnace room. Furnace room has incineration equipment, which is really high temperature, nearly 40 degrees, and workers are required to put dust mask on. You can see this picture. This is mine, and which is data collection at Ishikawa Hokuba Center, which is our field studies room and inference room. So you can imagine that harsh environment for workers. So high risk of heat stroke. And then we're talking about ensuring the safety of workers in incineration plants. First, incineration equipment requires periodic inspection. So ensuring the safety of workers when inspect these. So strategies for working with multiple workers now. However, in Japan, number of people who can actually work at the same time, which is 1.43 workers. So which easily imagined, it is difficult for multiple people to actually act at the same time. So that the need for indoor positioning systems. Field manager said, I want to know the location of the workers remotely, but expensive capital investments is not possible. So which means field managers is looking for a worker tracking system that can be implemented at low cost. And then indoor positioning technology is needed to track the workers. However, there was no previous study on indoor positioning assuming an incineration plant. So the purpose of this study is two things. First is we will study whether a low-cost indoor positioning method using only magnetism can be operated in an incineration plant. Second one, the experiment was conducted by collecting magnetism from a large area of an incineration plant. Next, I'm talking about existing methods on indoor positioning and implementation costs. The existing method is all of us, a lot of the methods, these, but the mainly is using Bluetooth or Wi-Fi based in the positioning. This is used, this positioning is estimated based on the reception strength and angle of the radio wave. Therefore, you can imagine easily, it is necessary to place beacons or Wi-Fi access points covering the positioning area. And then we focus on magnetism-based in the positioning, which is the magnetic field in the positioning range is acquired and compared during the estimation. This method called fingerprinting, and the fingerprinting is talked about later. And next, let's see this table. This table shows each method's positioning accuracy and implementation costs. First, we checked Bluetooth and Wi-Fi. These positioning methods is very good positioning accuracy. But before I say that, implementation cost is really high. On the other hand, magnetism-based in the positioning systems is normal, middle, so-so positioning accuracy. And implementation cost is really good, which is almost zero, because these in the positioning systems not required the implementation like beacons or access points whatever. So we focused on these magnetism based in the positioning systems. Then I'm talking about fingerprinting. Fingerprinting is really common method for in the positioning system or others applications. First, fingerprinting is the positioning is done in two phases, offline phase and estimation phase. And we can see these phases like these figures. Then the fingerprinting process is the feature of each location are stored and as fingerprintings and matched. So offline phase is we can collect it. We should collect it, the environmental data from research field. This figure shows that collecting devices is smartphone and our study is same, but you can choose other implemented devices. Then we collected every field area, the whole field area covered, collected fingerprints and the position. And they stored the database or something else. That is offline phase. And then estimation phase is actually using, for example, the workers has the smartphone in their pockets and they're walking around. And the system is processing these. First, the smartphone or some device collected the fingerprint, only fingerprint, because these devices can't imagine or can't analyze the places. So the devices check this fingerprint with within the database matching. So then location is found, and finally positioning is complete. These offline phase and estimation phase, two phases, this process called fingerprinting, and our study is really important techniques. And then I'm talking about dynamic time warping, which is an algorithm to calculate the geometric discrepancy between two time series data. And you can see these GIF animations, which is the calculating the two time series data's DTW scores. And this DTW has really robust to time transition and expansion and contraction. So that's why time series data with different measurement frequencies can be compared, So these features is really important, also important things. And finally, I talk about the last techniques, which is the decomposition of magnetic vectors. We have to get the magnetism data from each places, but each places has same metric or same values whenever the smartphone's angle is rotation, like whenever. So we're using an accelerometer, extract the vertical direction MV and horizontal direction MH of the magnetic field by scalar projection. After that, these MV and MH is regardless of the orientation of the sensor, the same magnetic field will result in the same value. And we can see that calculation equations left side and the calculation explain figures right side. So this right figures said, for example, the magnetic spatial magnetic field is like large n vector, like black array. So, and we also get gravity vector, the orange array, like G vector. So we calculate by gravity vector using like theta, get theta, and then we decomposition like using scalar projection to MH and MV. So that's why the next token, the explanation, we use MV and MH for as a fingerprint. So next, let's talk about environmental data and app for correction data. First, we've developed an Android application for data collection, which features data collection and connect to a laptop PC. Laptop PC, talk about later. And these figures shows a screenshot for Android smartphone when collecting data. And we collected environmental data is 3 topics: magnetic sensors, accelerometer, and gyroscopes. Each data has frequency like this. And we use measuring cart to improving the efficiency of data collection. We created built that, which means semi-automated position capturing. And we can see the right figure, which shows the cart outline, called out figure. And you can see laptop PC here. So the previous I said laptop PCs connect with under smartphone, which means this laptop PC connect with smartphone. And this cart collected environmental data. To measure the relative distance from the starting position by these techniques, which contains magnet in the wheel, beside the wheel, with Hall effect sensor. So the wheels is rolling. The Hall effect sensor gets the N pole approaches or S pole approaches. And then we can collect the how distance with the cart is moving. So next, we're talking about features of difference rule. This studies experiments difference room, one floor, which area is 60 meters by 79 meters. And you can see these pictures. You can see the laptop metal equipment, pipes, and grating. Grating is this is floor, like contained by metal equipment like this. So we expected to find an abundance of magnetic fields. And next, we talk about dataset. We collected the data on September 13th, 2021 at the first floor level at Ishikawa Hokubu RDF Center, which is located on Ishikawa Prefecture in Japan. And we collected offline and estimation phase. Each point has 1,024 points. And this figure shows where we collected the data. You can see these green lines, which is contained by the dots, the points. The points come together to form a line. So these passes is 24. The number of these passes 24. And each points in the paths are 30 centimeters apart from each other. all right? And then I talk about evaluation methods. We use 3 different methods to investigate the positioning errors obtained from our dataset: point matching and pass matching and DTW matching. First, I talk about point matching. Point matching compares our 2 points, like 2 points, actually 1 point and other points. Yes. So for example, target, which is estimation phase, target 1 point, and offline phase, all of them. And this method uses the difference calculation distance, like score, for comparison Euclidean distance, like here. So this method is the most simple method of the other 2 methods. And then the other side, pass matching and DTW matching, these methods perform multiple points matching along the trajectory. These figures explain how matching is pass match and DTW matching. This matching method is like that. We picked up target pass, which is not only 1, but also several dots line. You can see, you will see, you saw the green line, the picture. Take up over target pass and to compare the same length reference pass. Reference passes collecting by offline phase. So compare like this green array, point matching or DTW. And then, so why we use that? We consider that a worker walks around the factory, the incineration plant. We assume that a path connecting some reference points obtained in the offline phase represents his whole trajectory. Yeah, so we expect it to get better accuracy. Sorry, go ahead, please. Yeah. And then we talk about estimation error calculation. So we talk about estimation accuracy. So we check estimation errors. So we calculate these estimation error from point matching is calculation Euclidean distance between the points TXTY and EXEY, which is each point is TXTY is target coordinates and EXEY is estimated result coordinates. So point matching estimation error is this equation. And pass matching and DTW matching is calculate each Euclidean distance and take mean. So you can see the estimation errors calculation, this equation. Okay, so let's talk about estimation results. First, I show here calculation time. We measure the calculation time it takes to estimate all the targets. So the result is here. Point matching, pass matching, DTW matching is like this calculation time. It shows the point, pass, DTWs. This line is the more better to worse. You can see that. So this is the result of calculation time. And then we talk about estimation error. These figures and this table shows calculation estimation error. So we can find that the point matching is really worse and pass matching and DTW matching is really better, like same. And the estimation error table set also that. And then we more deeply talk about comparison of pass matching and DTW matching. So we can see this graph which shows path matching is a little bit lower Euclidean distance, so estimation errors with DTW. That's why, that's reasons why it shows this right graph. I think DTW is tolerant to changes in time, which is one reason why it matched reference points with similar shapes, and DTW matching these similar shapes like that. And DTW matching is estimation error is bit lower, which means high error. Lower than path matching 1, I think that. So conclusion, an Incineration field masters is looking for a worker tracking system that can be implemented at low cost. So we studied whether a low-cost indoor positioning method using only magnetism can be operated in an Incineration plant. As a result of verifying in 3 methods, point, path, and DTW matching, the path matching method was found to be the best method in terms of estimation time and accuracy. So that is my presentation. Thank you very much.